our next lesson is about cross-sections and rotations of two-dimensional objects, and this aligns with Module 3, Lessons 6 and 7 in Engage New York. In this lesson, we'll hit one CCRSM standard, and that is to identify the shapes of two-dimensional cross-sections of three-dimensional objects and identify three-dimensional objects generated by rotations of two-dimensional objects. So for our class, this is our bridge from flat geometry, two-dimensional geometry, now moving into three-dimensional geometry, and we'll be looking in the future lessons about volume. But today we're looking at cross-sections and rotations that are created by rotating two-dimensional things. Let's get started. Lesson 6 is about general prisms and cylinders, and lesson 7 is about general pyramids and cones. And to me, the most important vocab word of this lesson is on the second page, the word cross-section and the word intersection. Okay? Now, taking a three-dimensional solid or an object, a cross-section is where you're cutting it parallel to a base. Okay? An intersection would be any intersection or any cut in the solid. Okay? Now that's pretty important for us as we begin talking about these three-dimensional solids, is the idea of a cross-section, cutting it parallel to the base. Now let me go back here and talk about a general cylinder. I know that you're used to thinking about a cylinder as the shape of a can, where you have a circle top, a circle bottom, and every cross-section is a circle. Now a general cylinder is where the bases can be any shape. Okay, that's a kind of a strange shape, but the bases can be any shape, and a general cylinder is where every cross-section of this would all be the exact same as that base. And so it's a cylinder in general, but that base may not necessarily be a circle. Now, Engage New York does have some pictures that we'll look at during class time, but I want to go to some GeoGebra files that give us better visuals of what cross-section and intersections look like for both cylinders and for cones. The first one we'll look at is the cross-sections of a rectangular prism. So here is a rectangular prism, and in here in green I have a cross-section, and I can look at all the cross-sections of this rectangular prism, and they're all looks like squares or rectangles. Now these are cross-sections because they're parallel to the base. And if I move the angle of this, then I get intersections, and I can look at some intersections that happen here as well. Okay, not much happens really with a rectangular prism to look at. I'm next going to go look at spheres. And spheres might not surprise you that all the cross-sections of spheres, as I move this up, are all circles. Okay, and even if you rotate this around somehow, you still only get circles in the cross-sections of a sphere. With a cylinder, all the cross-sections are circles, like I mentioned before. If you twist this and look at intersections, then you get to have the ellipse shape we looked at a few classes ago. And next, a triangular prism. Again, may not surprise you, get triangles at all the cross-sections. If you slant this and look at intersections, then they're not congruent to the bases, but you still have triangles as intersections. Now I've left cones for last because cones have a lot of really interesting things that happen with them. If you look at cross-sections, you will get circles, which probably will not surprise you. Okay, if you tilt it, you get this shape, which is also an ellipse that we looked at a few class periods ago, like an oval. Okay, if you keep rotating this so that it's parallel to a base, what you actually get is a parabola. So we looked at parabolas. You've looked at parabolas probably last year in Algebra 1 as well. You get a parabola shape. Okay, if you keep rotating it so it's parallel, so it goes through the center, you get a triangle. But if I move this, and so it's not going through the middle, I get half of a shape called a hyperbola. Anyway, you look at all those in future math classes. but some interesting shapes happen when you begin to look at intersections in a cone. At least for right now, cross sections. We look at cross sections, we always get circles. All right, back in Engage New York on page 35, sketch the cross sections for the following figures. Now I'll just do A and B, and we'll do more of these during class. But this cylinder, and if you look at cross sections of this, what you will get will be a circle, and I'll draw that like a circle. Now if you're really particular, you'd have the same diameter and the same as the one above it, but that's okay, a sketch. It's a sketch of the cross section. Now this one, if you look at the cross section of this, the base is a pentagon. Both bases are, and it's a cylinder, and so you'd have a pentagon down here as well. I'm not sure if it's a regular pentagon based on the angle, but you'll have a pentagon as the cross section of that. And we'll look at some more of those next time in class. The next idea to talk about is what's called a solid of revolution. Let me scroll down here to give you a picture in Engage New York of what that would look like. Number 6, sketch the figures formed if the rectangular regions are rotated about the provided axis. So if you were to take this shape right here, this rectangle, and you were to rotate it around the axis, what shape would you get? Okay, and if we change what, the shape we started with, what kinds of solids would we get by revolving shapes, two-dimensional shapes around an axis? That's the second part of today's lesson. Here is a different GeoGebra file built actually for some ideas studied in calculus, but we're going to use this GeoGebra file to look at rotations that are created as you rotate two-dimensional shapes around a provided axis. Okay, we'll start with the one we looked at in Engage New York, where you have a rectangle and rotating it around an axis. Okay, now what shape do you think you will get if you rotate that around? Well, let's look at it. If we rotate that shape around, then we get a cylinder. Okay, if you get a cylinder, it would actually have a top and a bottom. But in this file, in this program, I only have just that line rotated around, and so I do get a cylinder. The next one to look at would be a triangle. And so if I have this shape right here, this triangle, and rotate it again around the same red axis, what shape do you think you'll get? Well, let's look at it. If I rotate that around, then I get a cone. You get a cone if you rotate a triangle around an axis. Okay, the last one we'll look at will be this one. If I rotate this shape around the red axis, what shape do you think we'll get? Well, let's do it. If I rotate that around, we get a sphere. Okay, we get a sphere. All right, those are just a couple examples of rotating something that's in two dimensions around an axis and getting a three-dimensional shape. So this video is about cross sections, which again are parallel to the base, and intersections, which are not parallel to the base of three-dimensional shapes, and looking at rotations of two-dimensional objects around a provided axis, and looking at what three-dimensional solids or objects are generated by those rotations. Thank you for watching.